Now that we have a pretty good understanding about how partial orders work, I'm going to talk about something called comparable elements in partially ordered sets. And remember, partially ordered sets can also be called posets. So we're first going to review the definitions of partial orders and partially ordered sets that we've seen in previous videos. We are going to recall the definition of a connex relation. And then we're going to define what it means for elements in a poset to be comparable. And finally, we'll look at some examples of these concepts. So recall some important definitions from before. First of all, if you have a set A and a relation R on that set, we say that R is reflexive if every element in A is related to itself. We say that R is antisymmetric if the only way we can have A related to B and B related to A is when A is equal to B. And finally, we say that R is transitive if whenever A is related to B and B is related to C, then A is related to C. And if we have all these properties, we have what's called a partial order. And again, for a partial order, we call a partially ordered set, also known as a poset. And if in addition we have this connex relation, we get a total order. And just to remind you what a connex relation is, a connex relation is where any two elements in A are related to each other in one direction or the other. So if you have two items A and B, either A is related to B or B is related to A. And R is a total order if it is both connex and a partial order. So what happens if a relation is not connex? Well, if a partial order R is not connex, it is possible then that we cannot put a given pair of elements of the poset in order. Remember, putting these elements in order depends on us knowing what their relationship is in the relation. So, given two elements in the poset, it may not be possible to say that one element comes before or after the other element in that relation. And so we can determine whether or not we can put the items in order by seeing if they are related. So we say that two elements A and B are comparable if either A is related to B or B is related to A. Notice that this is saying that when A is related to B, that means A comes at or before B. B is related to A says B comes at or before A. All right, so let's look at an example. The set A containing the numbers 1, 2, 3, and 4. And the relation R is just the subset relation on the power set of A. So if we take the two subsets in A, say the set containing 1 and 3, and the set containing 1, 3, and 4, those are comparable. And the way we know it's comparable is because one of them is related to the other. In this case, one of them is a subset of the other. The subset containing 1 and 3 is a subset of the set containing 1, 3, and 4. However, if we look at the two sets, one of which contains 1 and 3, the other containing 3 and 4, turns out those aren't comparable. And let's see if we can figure out why. Well, first of all, note that the set containing 1, 3 is not a subset of the set containing 3 and 4. And the reason is we know that 1 is an element of the first set, but it is not an element of the second set, so it can't be a subset. And if we try it the other way around, the set containing 3 and 4 is also not a subset of 1 and 3. We're going to play the same game with the element 4. 4 is in the first set, but not in the second set. And since those two subsets are not related in either direction, that tells us that the set containing 1, 3 and the set containing 3, 4 are not comparable. All right, so now that we have an understanding about how comparable elements work, I encourage you to go back to the file called partial orders directed graph and the next file after that called partial orders divisible to apply these concepts to those particular examples. Now, I should give you a little warning that some of the activities on both of those are related to something called maximum, minimum, maximal, and minimal elements. That is something that is going to be covered in the next video, so you should skip those for now. After you watch the next video, you'll be able to do those just fine, but for now, just do the exercises that you can.